All right, today I'm going to start going over Chapter 4. So we've done the first 3 chapters. We went over Chapter 1, the Intro to Computers in Java. We went over Chapter 2, Java Fundamentals. And we went over Chapter 3, Decision Structures. So Chapter 4 has got 2 different things that basically it discusses, and that is loops and files. All right, so as you can see, we'll talk about the auto increment and auto decrement operators, then the while loop, the do while loop, the for loop, accumulators and sentinel values, nested loops, break and continue, deciding which loop you should use, and then the chapter ends, the last 5 to 10 pages is on file handling. So I created this before class just so you could see it. And when you talk about loops, this should all be review for you. All right. You can have a pretest loop or you can have a post-test loop. With a pretest loop, as it says there, you test the condition before you enter the body. If the pretest is false, you never enter the body. If the pretest is true, you enter the body, you do everything in the body, then you come up and you check it again. All right? So the pretest has a while loop and a for loop. The post-test in this language has a do while loop. All right? So as you go through these, regardless of the type of loop that you're using, you've got to go through these 3 steps. You've got to initialize your loop control variable, or what I call an LCV. You have to test the loop control variable, and you have to alter the loop control variable, unless what you're looking for is to have an infinite loop. There is some code that you do want to run continuously, so you want it to be in an infinite loop, all right? But most of the time when you get into an infinite loop, it's the result of an error on your part. So if we look at this, we're going to look at all 3 quickly. Here's a simple while loop. So again, the 3 steps. Step 1, initialize your loop control variable. Step 2, test your loop control variable. Step 3, change the value of your loop control variable. So that should make sense to everyone in here. This is going to print out x equal 1, x equal 2, x equal 3, all the way through till x equal 10. After it prints out x equal 10, it adds 1 to the loop control variable. It now is not less than or equal to 10, so it falls out of the loop. That should just, like I said, that should be review for everybody in here. And again, when I said it's a pretest loop, if I did this, now how many times do I go through the loop? You don't. All right, because you test it before you go into the loop body. And if the test is false initially, 11 is not less than or equal to 10, so you'd never go through the body of the loop even once. All right, so that's a simple while loop. Now when you go up to here, now here's a for loop. Now think about this. Here's the while. All right. So if I just literally sit there and grab all of this stuff, copy it to the clipboard, and paste it in here, what's different? Well, with a for loop, typically you create the variable inside of the loop like this, so that line's gone. Also, you test it right inside of here, so that line's gone. And you change the value of the loop control variable, so that line's gone. So typically when you write a for loop, you'll end up writing less code. The for loop is called a counting loop because you need to know exactly how many times you're going to go through it. But since it's also a pretest loop, if I did this, again, I would never go through the body of the loop even once, because we test this here, and if the test is true, then we do this, jump back up, do this, and then test it again. So just like with the first example, this is going to print out LCV equal 1, LCV equal 2, LCV equal 3, all the way through to LCV equal 10. Any questions on either the while loop, all right, or the for loop? Any questions on those? Then we've got the do while loop. And again, what's different between the while loop and the do while? Well, let's bring this in here and copy it in. Well, int LCV equal 1, so that line's the same. while LCV less than or equal to 10. Well, that's still the same down here. Curly braces. All right, the same system.out, the same LCV, so that's the same. So what's different? Well, again, you should know this. There's two things that are different. This is a post-test loop. So even if this was this, we'd still print out LCV equals, in this case, 111,111. We'd add 1 to it, and then we check it. All right, so since this is a post-test loop, we always go through the body of the loop at least one time. You are guaranteed that. So sometimes what people do, what programmers do, is they write error checking code and they put it into a do-while loop. So they're sure that their error checking code runs at least once. Once they're sure that it runs and it's working the way they want it to work, oftentimes they will change it then from a do-while loop to a while loop. Two more things. First, these are all Boolean conditions, so they must be in parens. And second, this is the only time when you're doing any control structure in Java, you must put a semicolon on the end. All right. Other than that, you wouldn't want to do that. So those are the three basic looping constructs that we have in here. All right. They're also going to talk about increment and decrement. And again, this should be review for you. But if I come through here and I say int x equal 7, all right, then I say int y equals plus plus x. What is that saying? That is saying add 1 to x and take the value now of x and assign it to y. So when I get done with this, x is equal to 8 and y is equal to 8. On the other hand, if I do this same thing, oops, and I say x plus plus instead of plus plus x, now it says take x and assign it to y, then add 1 to x. So in this case, x will still be 8, but y will be 7. And it works the same way if you do the auto decrement operator. So again, if I put that in here and I say minus minus x, x minus minus, in this case it says subtract 1 from x, so x is now 6, and then assign the value of x to y, so that is 6. This says take the value of x, which was 7, and assign it to y, then subtract 1 from x. And if you understand that looking at it, there's no more to it than that. It really and truly isn't very difficult. The only thing is, you can only use plus plus and minus minus if you want to add or subtract 1. You can't use it with any other number. All right. Remember, if I did want to say here y equals, for example, y plus 3. So I can't say y plus plus, but here I could say that, or I could say y plus equal 3. We've talked about that in the last chapter. Those two things mean exactly the same thing. So again, that shouldn't be anything new to you. This stuff is set up basically the same way that it was set up in JavaScript last semester. All right. So when, whoops, that was good. So when you look at it, we have then already talked about increment and decrement, the while loop, using the while loop for input validation. We'll look at that in a second, the do while and the for. So we've already hit on a lot of the stuff that's in here. You should also know, going back to what I showed you before, let's just go back up to the first one, the while loop, that if I do this, and I come through here, and I say if LCV equal 8, break. Oops. Now again, you all should know this. This should say x equal 1, x equal 2, x equal 3, x equal 4, x equal 5, x equal 6, x equal 7. All right. And then after it says x equals 7, Then it'll add 1 to it, meaning that it's 8. It'll check it, and it'll say, does it equal 8? It does, so it'll break. So that will not print x equal 8 or x equal 9 or x equal 10. All right? Typically, especially if you're using a for loop, a while loop like this, that's okay. But typically, if you're using a for loop, you don't want to use a break in it. All right? There are exceptions to all rules. Yes?
If you had 3 equals, would it print the 8 then?
Java doesn't support the triple equals like JavaScript does. All right. Now, on the other hand, if I do this, if I change that to continue, now it's going to print out x equal 1, x equal 2, x equal 3, x equal 4, x equal 5, x equal 6, x equal 7. What? Since we're doing it up here, it'll come down here, and it'll say x equal, well, will it? Probably I should put that up here. If x is equal to 8, it's going to skip the rest of the stuff that's in there and go back up to the next iteration. Probably wasn't the best example. But break breaks you out of a loop. Continue basically stops the rest of that loop iteration. It sends you back up to the top of the loop. All right. So we're going to whip through this fairly quickly because we're going to write some code pretty soon. And then when we get done, we're going to look at these two things. We're going to get an introduction to file input and output because you're going to do file and I/O on one of your next programs. All right. And then we'll talk about how to create a random number. Okay. So the increment and decrement we've already talked about. If you need more than I gave you here, you can take a look at the examples that are in the book. If you put the plus plus or the minus minus before the variable, it's called prefix or pre-decrement. If you put the plus plus or minus minus after the variable, it's called post-increment or post-decrement. And they got a big thing here on 192, the difference between postfix and prefix. So the while loop, again, we've talked about. I don't like his examples because, he says stuff, again, while it's raining or whatever. So remember, again, Boolean expression, so it must be in parens. If you're going to have more than one statement, you must use curlies. I recommend always using the curlies anyway. The example he gives here on page 194 is the same one I gave you instead of saying, here number equal, he just prints hello 5 times. He does a good job in here, page 195 on figure 4-2, of explaining the exact syntax and what's going on in here. So if you look at that and you're still at all confused as far as what's going on, that would be a good place to start to at least take a look. Again, pretest, I already went over that with you. You already saw something like this, that since number is 6 and you're checking to see whether or not it's less than or equal to 5, you'll never go through that. All right? An infinite loop is a loop that never ends. Sometimes when you create an infinite loop, they're done by accident. This is an example. You're never changing the value of your loop control variable, which is number. So that's just going to keep printing out hello, 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 hello forever. All right. Eventually, it'll start taking control of the system resources, and it'll probably lock the machine up. All right. In worst case, in the best case, it'll just crash the program. Notice the semicolon at the end of the first line assumed to be a null statement and disconnects, so you wouldn't want to do that. Typically, if you do that, it runs through it once, and boom, no matter what's afterwards. All right, so you don't want to put a semicolon on the end. We've already talked about using the braces. Again, I've said this to you before. Gaddis does a good job in his programs, basically in his books rather, in every chapter of having one of these in the spotlight programs where he goes over the stuff he's been talking about. So if you're at all confused, take a look at the example that starts here on page 198, and it goes on to 199 and top of page 200. All right. Using a while loop for input validation. The good news is I already showed you this in the last program we did. All right. Remember that we talked about this before, that if you do an if statement, it's a one-time shot. So if I said right here, enter a number between 1 and 100, if that was an if, and I came back in here and still entered a number that was out of range, the second time it would take it. But with this being in a while loop, every time you come through here, it'll check, and if that number you put in was 0 or negative or greater than 100, you're gonna run through this forever until you put a value that's valid in there. So if you imagine where it says this, that was the next line of code. The only way you're going to hit this line is if in here you put in a number between 1 and 100. And also, it's not that this is a big thing. Some books will call this right here, they will call this a priming read, because it's a read. And if you put in a valid value to begin with, you never have to worry about going through the loop. It's the old saying of like priming a pump, to get the water to come up. That's the same kind of thing with a priming read in here. What if we didn't want a priming read? What if we wanted to make, always go in here? If I didn't want this, I just don't want that. I could have then changed this from a while to a do while. All right? So by putting that into a do while, I would never have to put in a priming read if I wanted to go that route. Different people have different programming styles. The do while, again, we already talked about being a post test. So you always go through it at least once, and you must have the semicolon at the end. All right? So he runs through a lot of the same stuff he's been talking about in here. Comes through in this do while loop, and he says, enter score 1, enter score 2, enter score 3. Then when you fall out of the loop, basically he comes through and he goes and figures out the average. So when you look in here, and the whole thing is in a do while loop. All right? I've talked about this before. Those of you who had me for class last semester, I kind of threw it at you a lot. But in here, we could have literally said repeat equals input.charat0 dot, I don't remember what it is in Java, like 2 uppercase. And if we had done that, then we'd only had to check for this. The way that he wrote it, you have to check for both of them because it would take either an uppercase or a lowercase y. So we can do it like that, or we could have added to this if we wanted to also. The for loop, again, is a counter control loop. So as it says, you must initialize your loop control variable, you must test it, and you must update it. Well, to be honest with you, that's a lie. Because if I want to, all right, in these examples that I've shown you before, I could do this. If I wanted to, I could come in here and type in this. That's an infinite loop. That means do it forever. And there is code out there that does that. What that means is whatever I put in here will keep running. So if for some reason I don't want it to run forever, then I'll need a break in there someplace. I'll have to test for something and break out. All right. Sometimes too you'll see this. That's also an infinite loop condition. Now for years I was a programmer for AT&T. And when we, a lot of the code that we did was set up in a while one loop. You wanted it to run forever. Back before the days of cell phones, you picked up a rotary phone, you wanted dial tone 24/7. So, the idea was that was the code that made that run was in something like this. Also, any of these can be left out. All right? If you can initialize outside of the loop if you want to, maybe you don't want to test, but normally you do, and maybe you don't want to update. All right? So he gives you, again, he goes through this on page 208 where he goes through every step that's going on in here. And as always, he does a pretty good job of explaining everything and how it works. So he shows here the numbers between 1 and 10 and what their squares are. Pretty simple code. Show me the number, give me 2 tabs, and then show me the number multiplied by itself. Just like the while loop, again, the for loop is a pretest loop. We talked about that already. Now, he says something in here that it's, it's kind of in passing, but it's sort of important. The only place that you should ever change your loop control variable in a for loop is right there, inside of there. You shouldn't change it inside of here. All right? But what if what I wanted to do, for example, in here, in that for loop, what if I didn't want to print out x equal, etc.? What if I only wanted it to go and print out, let's say, the odd numbers, as an example? All right? Right now, it's going to print out 1 through 10. But if I wanted just the odd numbers, I could say LCV plus equal 2. And then it'll add 2 to it each time. So it'll print out 1, 3, 5, 7, and 9. Otherwise, I could start it at 2, and that would print out all the even numbers. All right. In fact, I could even start it at 0 here if I wanted to print out 0. So there's a lot of different ways that this can be done. All right. You can declare more than one variable in here also if you need to. So I could have said for int number equal 1, comma, int x equals 7 or whatever. So you can put more than one initialization here. You can put more than one test here. You can put more than one increment or decrement there if you want to. Not done often, but you can. All right. Here's a user-controlled for loop. But if you notice in here, what we ask basically is, how many times do you want to run through this loop? All right. Once you answer it, now I go from 1 to the number of times you just told me you wanted to go through the loop. So the point is, when you work with a for loop, by the time you write the body for the for loop, you must know exactly how many times you're going through it. Okay? The reason that that's important is there's still a lot of applications out there. Real good example is like insurance companies, that you've got just a ton of records out there. You're going to add records, modify records, so updates and remove. So you don't know how many records you have. You wouldn't use a for loop for that. You would use a while typically. And in there you can check for, and instead of doing it like this, you check while not EOF. So while you have not reached the end of your file. You're going to see that in just a couple minutes. As I mentioned, you can have multiple statements in there. So he's got another example here, another thing with a count-controlled for loop here that starts on page 214, and it goes on 214, 215, and 216, where he shows the equivalence of miles, kilogram or kilometers per hour to miles per hour. All right. Then he goes through running totals. All right. Somebody tell me if I do this. Okay, let's say that I don't, I'm going to come back and I'm going to grab all the stuff for this while loop that's right here. All right. And I can just leave it the way it is. So I'm going to come through here and do this. So that's still going to come through there, and it's going to print out LCV equals 1, LCV equals 2, etc. What this is doing right here, what that line is literally doing is it's saying sum equals 1 plus 2 plus 3 plus 4, etc. All right? All the way to plus 10, which is 55. So sum right here is what's called an accumulator. It is accumulating a value. LCV is called a counter. So this is a counter. This is an accumulator. All right, so if I'm adding, typically with an accumulator, you're accumulating something. So you're adding to it in a program. All right, that's an accumulator. All right. what the variable that you use to figure out how many times you're going to go through a loop, that's a counter. All right, so he talks about running totals. I called it an accumulator. He also talks in here about a sentinel value. All right, and with a sentinel value, what a sentinel value is it's a value you wouldn't expect to have. So for instance, if I keep telling you to enter in test scores, all right, and so a valid test score would be 0 through 100. And I could tell you to keep entering scores until you enter a score of negative 99. That would be a sentinel value. That would be a stop kind of value. It would send something, a message to the system that I'm done. That's the end of my inputs. So that's what they're talking about in here. -1 is often used as a sentinel value. But you got to watch it because sometimes, depending on what you're working with, sometimes -1 can be a totally valid value. All right? All right. One of the best programs in the whole book, in my opinion, for whatever that is or isn't worth, is this one right here. It's too bad that he didn't put it on one page, but he didn't. By sticking that in there like this, these lines here, and then these lines right here, that literally, in about what, 20 lines, creates, and I guess 15 lines, creates an entire clock. But the idea is if you can understand what's going on here, you get loops. This is going to go through there and it's going to say 1, 0, 0, 1, 0, 1, 1, 0, 2. So this one will keep going, and this one will keep going, and this one will first go from 0 to 59. So 1, 0, 0, 1, 0, 1, 1, 0, 2, 1, 0, 59. All right, once we get to 1, 0, 59, now I'll bump out of that loop, and that'll go to 1, 1, 0, 1, 1, 1, 1, 1, 2, up to 1, 1, 59. And eventually it'll keep going until it gets to 1 hour, 59 minutes, and 59 seconds. Then this will be bumped up, that'll go back to 0, and that'll go back to 0, and you'll do it again. So with simple 20 lines, you can write yourself an entire program that simulates a clock. The only change I would have made is I would have started that with 0, and I would have basically done it that way to put it kind of in military time. But there's nothing at all wrong with the way he did it. And he goes through this and explains it in detail here on page 222 as far as what's going on in there. All right, then he does a thing with test scores. And he's got another one of these in the spotlight things so you can print pretty patterns. All right, so how many rows, how many columns? So that's what? Basically, that's 5 by 10, right? 5 rows, and each row has 10 columns in it. All right. And he talks about break and continue, which we've already hit on. So I'm not going to, I don't know if he says anything that I haven't already said. All right. Deciding which loop to use. More than anything else, deciding what loop to use is a matter of programmatic choice. So it's the one that seems the easiest to you. If I know exactly how many times I'm going through a loop, I personally use a for loop. All right, if I don't know, 99.999 times out of 100, I'll use a while loop. I hardly ever use the do while. All right. So we went over that fairly quickly. Any questions on any of that stuff? All right. Then let's go towards the end of the chapter here. So we're on page 230, and we're going to talk about, basically in here, file input and output. All right. We're going to look at files in this chapter and maybe revisit it in a later chapter, but the idea is every single program you've written thus far, be it the BMI program, any of the payroll programs, any program, all right? There's been 2 big features about those that are going to change in this chapter. Number 1, every single time we want to run our payroll program, so if we have 50 employees in our company, the way that payroll program works right now, we're going to have to run that program 50 times. We're going to change that in just after the break, because we're going to go back and rewrite that payroll program, and we're going to rewrite it using a for loop. The other thing is as soon as you put in the stuff for the current employee, all right, and you get done and you put in another employee, that first employee is done. You're not saving any information. So typically when you want to save information, you do it in one of two ways. You're either going to send it to a database or you're going to send it to a file. All right? So we're going to talk about files in this chapter. And I don't want to sit and read to you. You'll notice that you end up using Print Writer, and there's a few of these different things that are in here that you'll want to use. Okay? Just a couple things as we get started. The way that this stuff typically works is unless you open up a file in what's called Append Mode. So if I open up a file for writing, and that file has 1 million records in it, and all I do is put my own record in at the end, if I forget to open up that file in Append Mode, all 1 million of those records are lost. They've been replaced with just that one. Typically, that's not what you're going to want to do. All right? And if you have an output file, what's going to happen is the system will look and it'll say, well, I don't care if it exists or not. It puts what's called the file pointer at the beginning of the file. And then it starts writing, and it overwrites anything that was there previously. Now, this is new in that, as they mentioned down here, when you work with a file, there's a few things you have to remember. You've got to open up a file first. Then you either write to the file or you read from the file. Then when you're done, you close it. And believe it or not, the one out of these three that's up here in blue, the one that's least important is number 3. Because if you forget to close a file, the file automatically closes when the program is done running. The problem is, and maybe you've gone through this before, that if you leave a file open, and we're about a month, maybe 6 weeks away, where we'll get a lightning strike or whatever, and everybody's machine will go down. If the file's open and you get a power hit or whatever, that file can be corrupted. So especially with databases, which can hold millions of records, it's important to open it, do your work, close it. All right? In general, there's 2 different types of files. There's text files, .txt, which you can read, and binary files, which you can't. When you want to go work with files, you'll need that at the top of each one of your programs. Import java.io, Java input output. You've seen this before, but again, if I come out here and I type in java.sun.com, go down here to the APIs, and somewhere down here, maybe it's up here. Java.io. All right? And you'll get all the information, all the stuff that's in there for it, but there's a boatload of stuff in there for it, okay? All right. Now, he goes through this, and it looks a little ugly. It says to write data to a file, you need to create an instance of the Print Writer class. So you need to do something like this. And when you do this, again, if output file did not previously exist, it will be created. If it did exist, it'll be overwritten the way that this is set up. So this is a file. This is where you're going to save it someplace. By default, you'll typically save it into the same place, all right, into the same place where your program is. So that's going to sit there and save this file as student.txt. But when we work with it in the program, it'll be called output file. All right? So you do something like this. I already mentioned that to you. If the file you're opening already exists, it'll be erased, and an empty file by the same name will be created. He's being very sloppy there. That's not really what happens. It's not erased. The file has got an invisible thing called a file pointer that gets moved to the beginning of the file. The file is never erased. So, look kind of familiar? We've been saying system.out.println, but now we're going to have the name of our output file in the program, .println. So that example right there, rather than writing that to the screen, which you still can do with system.out.println, that's going to write it to a file. So that's what you're going to see when you get done. Jim 95, Karen 98, Bob 82. All right. Again, we could have made this a print and then that a print line, and then we could have had Jim 95 on one line, Karen 98 on another line, Bob 82 on another line. It's all a matter of choice, the way that you do this stuff. The print method, as it says, is used to write an item of data to a file without writing a new line. All right, so again, rather than print line, print. So if we were going to write a whole record of information, that's probably the way we do it. Notice that the last one in here is a print line. All right, this is what's new. We're going to be putting that at the end of our main line. Throws IO exception that you see right there. Now, I go off on a little tangent here, but just so you know, when you see the word throws with an S on the end, that means Java's doing it. When we get to Chapter 11 next semester, you'll see the word throw, not throws, throw. You throw, Java throws. And what this means is you're sending a signal to Java saying, hey, it's possible the file that we're going to work with in this program doesn't exist. Why wouldn't it exist? Maybe I typed in the wrong name. Maybe I don't have permissions to write to a file or read from a file. Maybe the disk is full. That typically doesn't happen today, but you get the idea. So what that does is it tells the system we're working with something that's going to be working with files. And it's not inconceivable we could run and have some kind of an error. All right, so what that's saying is it's possible that our program, Java itself, could throw an input-output exception. All right. I don't know why he's got this fixation in here. How many friends do you have? Put the name of your file name in there. Then enter each one of your friends' names. All right. I don't know why, but then let's show your friends. All right. So on 235, he says here in the review that's on the bottom of the page, he said, before moving on, review the basic steps necessary to write a program. First, you need to import java.io.star. All right. Second, since we have not yet talked about exceptions, since they're not discussed until around Chapter 11 in the book, any method that uses any kind of print writer object, anything with files, must have a throws IO exception clause in its header. All right. Then finally, as it says, you create a print writer object and pass the name of the file. Okay. All right. So notice to append data to an existing file, you create an instance not of the print writer, but the file writer class. And you put on the end true. What that means is instead of taking that file pointer and putting it at the beginning of the file, move it to the end of the file. So don't overwrite what was there originally. All right. So as it says, you typically do a file writer, and then you do a print writer based off of that file writer. And if you want to get really tricky, it is possible to combine these into one line. For where we are right now, it's probably just as well off to do it as two lines. All right. Specifying file location here on page 237. Well, you know, with Windows, since it uses the backslash, you got to do it like that, which is really ugly. So even though with Windows, when you're putting in file components, you use the backslash, Java lets you put in things with a /. I'd recommend you do it that way. To me, that's much easier to do this that you see here in blue than it is to do this. If you want to do it the other way, you can. But if you forget one of these, it's going to be screwed up. So that was writing. Then to read data from a file, it says in Chapter 2 you learn how to use the scanner class. All right, that was with system.in, and when we were done, we had to close that scanner class, okay? And they show the next line. That's all stuff we did before. It talks about positions, etc. For what we're doing in here, think about it. It is possible in Java to open up a class with both read and write permission, okay? Which means that you can read stuff out or read stuff from the file and write stuff to the file. Almost always you don't do that. If you're going to write to the file, you open it up with write permission. If you're going to read from the file, you open it up with read permission. It's possible to take the same file, open it up in write permission, write to it, close it, open it up again in read permission, and read from it. It's more often done like that for safety reasons. All right? All right. Adding that throws clause, again, that's what they talk about in here, was that with the I/O exception and exactly what's happening. He's got a file where he reads a bunch of numbers from a file, because you can read in anything you want from a file. All right, you can read in names, you can read in numbers, you can read in whatever. Notice again, java.io.star. Notice again, throws I/O exception. All right. So he reviews this also on 244 on the bottom of the page. Again, there's other ways that you can do it like this. He is showing you the simplest way to read from a file. You're not going to have to do anything with reading from a file. But if you want to, you can take a look at it on here. All right, if you want to check to see whether or not a file exists, it's a hard one to remember because it's called file exists. All right, that line that you see in blue there on the top of page 246 literally is saying, go in check, and the file class has a method in it called exists that's going to return true if there is a file by that name and false if there's not a file by that name. All right. Notice we've got another thing here. While input file dot has next. It's another file method. What it does is it's called a look ahead or a peek, P-E-E-K method. It looks to see if there's another record. Eventually it'll say, oh, I reached the end. There is not another record. So has next will eventually become false, which means I've read the entire file. He's still on his how many friends do you have? So, all right. And the last thing that's discussed in the chapter, starting on page 249 and going on to 249, 250, and then there's a program on 252 to 254, is on how to work with random numbers. All right? You will work with random numbers in one of the programs that you're going to do. All right? So when you want to work with random numbers, the first thing you do is you make sure that's at the top of your program. Import java.util.random. All right? Then you come in here, and what this is doing is this is creating a brand new random number object. All right, it's called random numbers. And as it says right here, it declares a variable named random numbers. Its type is type random. So it's creating an instance. This is an object variable. This is not a simple primitive variable like an int or a double or a float, all right? And again, the equal sign, as it says, what that's basically saying is assign an address to that variable, all right? Now, if we do this, if we say number equal random numbers dot next int, that'll give us a random number. I think it's between 0 and 2 billion something, between negative 2 billion something and positive 2 billion something. That's not typically what you'll want to do. So typically you'll want to do this. What that line is, imagine for a second, in fact, let me grab this. If we do this and we leave off that, that gives us a random number between 0 and 9, not between 1 and 10. Because the way that any random number generator works by default is it gives you a random number between 0 and less than 1. So up to 0.99999, whatever. All right? But by adding 1 to it, what that says is next int, that's by itself is going to give us a random number between 0 and 9. But if I add 1 to it, now it's a random number between 1 and 10. So for your program, you're going to be doing something like this because you'll want to generate a random number between 1 and 100. Yes?
Could you do 101 instead of adding the plus?
Yes, but that means that you could have 0 in there. So again, as always, it depends on what it is you want to or what you're trying to do. All right. So you'll notice there's a next int, a next double, a next float. These are all basically all of the different, or just about all of the different numeric types. There's not a next Boolean because that doesn't make any sense. All right, so he's got this math tutor in here where basically he puts a random, he generates a random number between 1 and 100 and another one, and then he says, okay, what's the answer if you add these two? So the idea is if you do this, you build this and you give it to a little kid, if they kept running the program, ideally it would keep giving them different numbers. All right. And he's got another thing here with die. So you work with dice. Okay. All right. I think that's pretty much it for the chapter. So again, always read these common errors to avoid. There's some good stuff in here. When we come back from the break, I want to make sure you're into Eclipse, and we're going to grab that payroll program, the last one that we've done, which was like 3 or something like that. We're going to copy it to 4 and go on from there. Yes?
What if you did want to do it like random true false?
Well, what I would do would be that I would just generate a random number. I would use next int, and I would put in 1, which would either give me a 0 or a 1. And then 0 I'd make false, and 1 I'd make true. Okay. All right, so let's take a break. It's 10:51. Let's come back at 5 after 11. Get into Eclipse and bring up your last program that you had, your payroll 3 or whatever the heck it was.